Hi students, today I will discuss a special type of convolution encoder. In the following slides, I will tell how that type of encoder will be created. After that, for encoding process, determine the generator sequence corresponding to the encoder, required formula used for encoding techniques, and lastly, an example to show that encoding process. As you know that in case of convolution code, the number of input and output may be more than one. In our previous example, I solved the encoding techniques which has two output and one input. In this type, I will show a case where number of input is also varied. Note that in this type of problem, the memory order used for one input may not use for another input, unlike our previous example. So consider the following figure. The dimension of the encoder is 432. Why? Because here number of input is 3. As you see the picture, there is 3 input and number of memory, that is maximum memory of this present in this structure, which is 2. So see in last line there is 2 memory present in that structure, and with that means the memory order is 2. And lastly the output, which is denoted by these 4 square line square, which is emitted from 4 modulo 2 adder. That's why it is named 432 convolution encoder. You know that to indicate the dimension, first we write the output, then we write the input, and last the memory order. Now, from this figure, first we have to find out G, or generator sequence, that is link that are connected from one input to one output, with or without memory. In our previous example, for two output and only one input, I took G suffix 1 for one output and G suffix 2 for another. But here, as input and output both are present and they are varied, hence we use Gij, that is G suffix ij, indicating the generator sequence connected to which input and which output. Here I represents the input value, number of input present in that encoder, and J represents number of output present there. Here G suffix ij equals to G suffix 4 and 3. Why? There are 4 output and 3 input. Therefore, it is indicated as G43. G suffix 43. So, I have to find out from the link from G11 to G34. That means G11, G12, G13, G14, then G21, G22, G33, G24, 31, 32, 33, and 34. Again, you can see that number of maximum memory used here 2. So by considering the present input and previous 2 input, that means for the present input, that is input, and previous 2 input, that is the memory, maximum memory present here. In all cases, you have to find out 3 generator sequence for each input and output. Now for calculating bits of generator sequence, remember that principle which I am telling now. If one input is directly connected with any output, the first bit of generator sequence is made 1. In other cases, if input is connected by a memory to output, then consider the memory bit position and indicate that position as 1 for G value. If number of input is connected to output, is not connected to output, for any cases, put G is equal to 0. So for our figure, consider the first case. The first input is directly connected to first output. Here, see the link. There is no memory through this link. So input is directly connected to this output. Therefore, the first bit of the generator sequence G11 is 1. Now, we, other than this direct link, no other link is present with a memory, or in this link no memory is present. Therefore, the other two bit is 0. Therefore, G11 is equal to 100. Now, consider the second case, that is G12. That means the first input is connected to second output. The link which connect the first input to second output. So there are one direct link. This link is connected here. See. Therefore, here also the first bit of the generator sequence is 1. Sorry, here 1. And no other link is connected from this input. See, from first input only this link is connected. Other than this link, no other link is present, which is connected from first input. So, the other bits are 0. Likewise, G13, G14, all are same value, that is 100. The input 1 is connected to output 3 by this link, and there is no other link. And G14 is connected by this link, and there is no other link. Now consider G21. 21 means second input is connected to first output. By which way? See, there is no link which connect the first output and second input. Therefore, the value of generator sequence is 0, 0, 0 here. So G21 equals to 0, 0, 0. Now consider G22. 22 means this output, this input and this output. Here, see, this, there is a link between this, a direct input between second input and second output. And there is also present a link through a memory. See this link, there is a memory which is connected to this output. And no other output is present which is connected from the second input. Therefore, the link is 110. See, input second and output 3. That means G23. There is no direct link present between 2 and 3. But a memory is link is present through a memory through this line. So therefore, this is also 0, 1, 0. G24, see, this is 2 and this is 4. So there is a direct link between 2 to 4 and no other link is present. Therefore, G24 is 100. Likewise, you can calculate the other value of generator sequence, that is G31, 32, 33 and 34. These are the value. You can check it and by yourself do the formula, use the formula and write the sequences. Now, to calculate output, We consider this formula V is equal to U into G, where U is the input sequence and G is the generator sequence. By indicating output and input, formula becomes this: V of ij equals to U of I into G of ij. As J is the as J the output arises from ith input. That means jth output comes from ith input. The rth component of the Vij, that means Vr suffix I comma j, it is called rth component of Vij equals to Uri plus G0 I suffix G I comma j plus U R minus 1 suffix I G1 suffix I comma j plus U R I G2 ij. This is the main formula which is used in this case. Now, by considering all generator sequences in their position, you can solving the equation, the previous equation, and we can get this formula, that is Vr1 equals to U of R1, where putting the output as output is important here, so I only represents in the equation output, not the input. Therefore, Vi represent, that means I1 equals to here represents the jth value. So, by solving these four formula will create it, and thus the output sequence comes from represented by this formula. Now I am discuss one example which can represent or which can tell the total formula by a specific way in more detail. Determine the output sequence from the convolution encoder 432 given in the following figure, where the input sequence U1 equals to 101, U2 equals to 110 and U3 equals to 011. So by taking U0, U equals to U0, U1 and U2, and by taking R equals to 0, we put the formula VR, that means V01 equals to U01. Just put the value in this equation and consequently you can get this value. V0, V1, V01, V2, 1, V01, V02, V03, V04 is like here. Now U01 equals to 1. Why? Because this is U01, this is U02 and this is U03. So considering these three value, we can easily calculate this value. Check U by 1. This is U01 plus V01 equals to 1. V02 equals to U01, that is 1, and U02, that is also 1. That is equal to 0. By this way, we can calculate the total one. So all V0's values are calculated here. By this way, you can calculate by R equals to 1. By taking R equals to 1, the total formula, and R equals to 2, R equals to 3, and R equals to 4. In all cases, you have to consider the formula and place the R value, Rth value in the equation, in this equation, and by this you can get our result. As number of output is equal to 4, hence R equals to 4. So final output will be V equals to this. You check it and do yourself. Thank you. If you have any doubt, do yourself. Thank you.